All right, our last installment for Unit 1 test. This is a review of the labs on free fall that you did in class. So free fall, we talk about something that is falling through air, but we pretend that there is no air, just like in the video that you saw from the moon, where the astronaut dropped a feather, a falcon feather, and a hammer, and they hit the ground at the same time because of there is no atmosphere on the moon. And therefore, if we pretend that there's no atmosphere on Earth, we can assume that everything is falling with the same acceleration. So when we talk about free fall, we pretend there's no air and therefore no air resistance. And if there's no air resistance, then everything that is falling down is falling with the acceleration due to gravity or acceleration of gravity. And the little letter G is used to represent it. Now, mind you, G is not gravity because G is acceleration and gravity is a force that causes it. So do not call little g gravity. It's acceleration due to gravity or acceleration of gravity. Now, it's different on different planets and furthermore, it's at different points on our planet. But the well-known value for it is 9.81 meters per second squared to 3 sig figs, and it fluctuates from 979 to 981 depending upon where on Earth you are. It's always downwards, and therefore it is habitually used with a negative sign because negative means going down. Let's review the ball drop where you were figuring out the height of the room, or it could also pertain to the reaction time where you were catching a ruler. Anyway, so something that was dropped, we could figure out the displacement of something that is dropped using the formula delta x equals v final plus v initial over 2 times change in time if we measure it. However, we would need to know the v final. So instead of using that formula, it's easier to use this one because for that one, we already know that initial velocity, if we drop something, is 0. And then if we time it, the first part just basically disappears and we end up with just 1/2 acceleration t squared. And if again, we pretend that this is free fall and there's no air, then we can assume that acceleration is negative 9.81 pointing down meters per second squared. So that's what you did. You dropped a lacrosse ball from the height and then timed it over and over again. Let's say on average your time was 0.63 seconds after you averaged all your times through the several drops. Using that time and this formula right there, we can figure out the height of the room. So if we say 1/2 acceleration times squared, that would give us 1.9 meters. Well, technically it would be negative if we use negative 9.81, but again, it fell down, so yeah, the displacement, if we're talking displacement, would be negative 1.9 meters. And as far as the height, you just say 1.9 meters. If we were to find the final velocity, you had to do that for the ruler, the one that you were catching when you were figuring out your reaction time. V final could be found as V initial, so V final is v initial plus acceleration time, and in our case if it was dropped from rest, then initial is 0, so we don't even look at it, and acceleration times time is 0.63 seconds, acceleration 9.81, 6.2 meters per second, and it's downwards because acceleration was downwards. So this was for the drop of the ball to figure out the height of the room. Now the second one was when you tossed a ball, and you tossed the ball and timed yourself from when you tossed it to when you caught it. And that basically implies that there are two parts. There is a ball rising to the maximum height where it stops, and the speed at the top is 0 because it stops, and then it reverses. Now the thing is, no matter which way it's moving, the acceleration that it has, because we assume this is free fall, is always 9.81 meters per second squared downwards. So if you look on the right and on the left, you see that everywhere I'm saying g is negative 9.8 meters per second, I'm showing that it's downwards, that's why it's negative. So on the way up, it's slowing the ball down to 0, but on the way down, it is speeding up, so it's speeding up back and ends up with the same velocity, only well, I should say with the same speed, because velocity will be opposite. It's negative of initial velocity. See, this V final equals negative V initial. So in that part of the lab, you were asked to time yourself, and then there were two questions. You were three actually. You were asked to figure out the initial velocity with which you tossed it, the final velocity with which it hit your hand, and also were asked to figure out the top, the height, three different ways. And that's what we're going to look at now. So for option one, if your total time is 1.24 seconds, then for option one, we're going to split that time in two. So that will give us 0.62 seconds. So in 0.62 seconds, the ball went up, and then the next 0.62 seconds, it fell down. So G is the acceleration that the ball had, because we assume this is free fall. And so on the way up, V final was 0, because that's where it stopped. V initial is what we're looking for. 0.62 is our time, and acceleration is negative 9.81. So that's the formula. So when I'm asking you to show me the formula, I'm asking you to show me the values. So this is the formula. So when I'm asking you to show me the formula, I'm asking you to give me the symbols, the Greek letters or Latin letters, whatever. And then after that, you can actually put in the values. So on the right, this is with the calculation. So you are plugging in the known numbers. You know V final is 0, 62.62 seconds is the time, and negative 9.81, because it's downwards, is the acceleration. And then when you multiply 0.62 times 9.81, you end up with 6.1 meters per second. And the minuses, the two minuses, take care of each other, because you will end up with negative V initial equals negative 0.981 times 0.62. That will give you a positive 6.1 meters per second squared. Meters per second. So that is your initial velocity. Now the final velocity on the way back is the same, because it will accelerate through the same amount of time with the same acceleration, and the final velocity will be negative 6.1 meters per second. So if you toss something upwards and caught it at the same height and assume that there is no air resistance, then your final velocity is the same as initial, only with an opposite direction. So it could be a negative if you consider it. So the second option is if I use the full time, the full 1.24 meter, so if I use the full time of 1.24 seconds, then in my option two, what I'm going to do, I'm going to use the full time, and I will realize that my final velocity with which it hits my hand, the ball hits my hand with, the final velocity that is opposite, equal but opposite to initial. And then G, which is formula for acceleration, G equals V final minus V initial. In this case, V final is opposite of V initial, so we end up with negative 2 V initials over time equals G. So then you just multiply G times change in T, and you divide it by negative 2, and that will give you your 6.1 meters per second, the same velocity. It's just two different ways to solve it. So if it makes more sense for you to split that motion into two and consider final velocity to be 0 at the top, then use half time and figure out your V initial. Or you can use the total time and just realize that V final, when it hits your hand, is opposite of V initial with which you tossed it. Now, height of the toss, there are three different ways to find it. Way one, right here, what we have is change in X, V initial plus V final over 2 times time. Remember, you are figuring out the maximum height. The maximum height was achieved in half the time. Initial velocity is 6.1, final is 0, 0.62 is your time, and you multiply that and you get 1.9 meters. The second, you can use the time square formula. So V initial, again, time is half time, because in the half of that 1.24 seconds, if you timed yourself and you got 1.24, whatever else you got that's in your lab, you half that time, and then you put it into the formula. Now, the very important part is to remember that you have negative 9.81, because 6.1 was positive, it was upwards, but 9.81 is always downwards, so you will have to put the minus in there. Otherwise, you're going to have a wrong answer for your displacement. And then finally, the last one is the third way to figure it out, and that's the v squared. So you have v final squared equals v initial squared plus 2g delta x. V final at the top is 0. Delta x is what you're going to look for. So when you rearrange, it's v final squared minus v initial squared over 2g to give you delta x. Final is 0. 6.1, we had figured it out before. You square it and you divide by 2. And remember, again, negative 9.81. That's how you end up with a positive displacement, because the displacement was technically going up, and therefore it was a positive 1.9 meters. So that is your lab, and that is also one of the examples on the test.